Hello, welcome to ME 510, Economics and Policy of Engineered Energy Systems. This presentation is part 4 of the first module of the course on the origins of fossil capital. We're going to switch gears and talk a little bit more about the role of energy in the Industrial Revolution and modern economic growth. So one key question that we have to ask is how important is energy to driving economic growth? If you look at this graph, you will see that uh, economic growth has increased significantly since the 1980s. And this has been accompanied by both an increase in energy use and a similar increase in CO2 emissions. So certainly there is some role here in energy, but we can see from the widening gap towards the right that energy appears to have a much lesser impact on GDP growth. And let's try to understand why that may be. An example of a country that we could look into is Sweden. And in this plot, you're seeing the shares of primary fuels from 1800 to 2000. Uh, as many nations, fuel wood, for the most part, was the primary source of fuel. And again, this is on a percentage basis. So the total amount of energy has increased during most of this period. But in the beginning, fuel wood, animal power and human power were the primary sources of energy. As with many countries, coal was dominant for a large period of time. You'll see that for many countries, including modern developing countries, fuel wood, human power, animal power can be significant sources of energy. And eventually, coal was overtaken by oil in recent years in Sweden. Primary electricity, possibly renewable sources of energy, and things like that are also a significant contributor to the energy use in Sweden in recent years. However, one intriguing finding about Sweden specifically, but you can find this trend in other countries as well, is that the value of energy relative to GDP has been decreasing significantly. And what this is trying to show in this plot is that that value, if you index it to 1 starting in 1800s, it's actually a small fraction of what it was in the beginning. And so we'll call this the cost share. And it's not consistent with normal growth models that the cost shares should decrease. What this is trying to indicate is that when a country's economy grows, it usually grows by using more materials, using more energy, and um, assuming that you are using different types of energy over time, um, you should be able to substitute, for example, 1 megajoule of coal with 1 megajoule of oil and still produce a similar amount of gross domestic product, but that's not the case. Um, in other words, if the price of one factor, like energy, goes up, there should be a structural change so that less of that factor is used. And you can think of that as energy efficiency. And so the cost share will stay constant. So if you look at gross domestic product for a country like the US, and you look at the energy that goes into, for example, lighting up buildings, if the price of electricity goes up, then the use of electricity should go down. Consumers should switch to higher efficient light bulbs, but the overall cost of using electricity should be the same. So in conclusion, it looks like increase in energy and energy augmenting technology is critical for an industrial revolution, and that labor augmenting technological change was most important after World War II period. So what does this mean? It means that in order for nations to have revolutions, technological revolutions, not only do they consume more energy, but they also have to adopt technologies that allow them to use that energy more efficiently. Here's an economic function that helps relate this in terms of an equation that could be used. This is shown here for illustrative purposes, but this equation, the Cobb-Douglas equation, also known as the original production function, is a formula that relates the gross domestic product, Y, to the labor hours, physical capital, and the total factor productivity. Okay? The exponent alpha is the wage share of gross domestic product. So this is how much are the laborers paid as a function of of GDP. Okay? And that wage share should correspond to the marginal contribution of labor. So what is the marginal value of adding another worker in terms of the money that they're able to, or the gross domestic product they can generate? This equation is useful because it allows us to look at how improving certain factors like the physical capital, machinery, and buildings can have an impact or influence in gross domestic product. And it can be applied to different sectors, different countries, and different regions. So we've talked about the Sweden case, and this is happening globally. Why does it appear that energy is less important, particularly after 1950? One possible reason is that energy has become abundant and cheap, but this is likely just an illusion. Um, a more convincing argument can be made that the economy is growing now not just on the basis of energy. Energy does contribute to economical growth, but there are new aspects of the economy that are helping grow faster, such as information technology or IT. Some supporting evidence is that if you look at modern industrialized nations like the US, Japan, UK, and Austria, the amount of useful work that is done as a function of GDP is actually decreasing since 1950. So what that is suggesting is that we're actually able to produce more with less need for labor or work. And this is happening not just in developing countries, in developed countries, but developing countries are also taking advantage of IT. However, there are many developing countries that are undergoing both a second and third industrial revolution at the same time as they adopt IT. What this is doing is that different parts of the world are seeing a demand pool. We've seen this in some rising prices of energy, although in recent years coal and oil has been decreasing in value, in price. But one thing that we have to keep in mind is that as it relates to fossil capital, we are seeing some impacts on our climate related to fossil use, particularly coal. And so if we are going to move away from fossil fuels, that's going to have some kind of impact to economic growth and welfare. And those are questions that we'll try to answer throughout this course.